Vectors and Calculus, Day 1. A vector is represented by a directed line segment. Vectors are equal if they have the same length and direction, in other words, the same slope. So we have, this is the tail, that's the head, and we have an initial point and a terminal point. So a vector has a direction and has magnitude. It doesn't have location though. Students will be able to find the component form of a vector, the magnitude of a vector, and the direction angle. Explanation of speed of object given velocity vector. Car A's velocity is defined by these 2 points right here. And car B's velocity is defined by those 2 points. And it's given as a vector. Over here on the green line, here are the 2 points. Here's the beginning, the initial point. Here's the terminal point. And with car B, it's the blue. Which car is going faster? Well, if we look at the lengths of the vectors, or the magnitudes of the vectors, I wanted to make it very clear that car A is going faster. But now let's discuss how much faster. Let's give it a value. To answer question 2, we need to put the vectors in what we call component form and find out how long they are. So the magnitude, well, no, let's go component form. Vector A is equal to, and we do a component form with what we call chevrons, and I've seen it done with parentheses too, so it doesn't matter either way. But component form means we want, if we start from beginning to the end, how far is that? What is that x distance? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. But to get that, we can take 6 minus negative 3. So we take the end minus the beginning. 6 minus negative 3, and then the distance from beginning to end for the y ends up being 2 minus 8, which is negative 2, let's just go 2 minus 8, which we know to be negative 6, but this is 9, negative 6. There's the component form, which means that we don't really have 2 points to define this vector. We only have 1, and that the first point is at 0, 0, and if we go over 9 and down 6, we're right here. So those 2 green vectors are the exact same vector because vectors don't have location. They only have direction and magnitude, or direction and length. Now if we do the same thing with B, we get 2 minus negative 4 and 0 minus 4. So the component form for this is 6, negative 4. So now we're going to start the blue one here, car B, and we're going to go over, over 6 and down 4. Over 6 and down 4. That puts us right here. Now we can see that both cars are going the same direction, just the green one has a longer velocity vector, which means it's going faster. So the magnitude of car A is the square root of 81 plus 36. In other words, it's the hypotenuse of the triangle, of the right triangle that we could create. We have the square root of 117. Now the length of vector B is square root of 36 plus 16, so square root of 52. Now if we want to know, well, how much faster is the green going? We can do square root of 117 and then minus the square root of 52. And that's going 3.605, let's say, miles per hour faster. But we've assigned a value to how much faster is it going. A vector is in standard position if the initial point is at the origin. So here we have a vector in standard position. It has an angle and it has a magnitude, or a length. The component form of this vector is, well, we have the x-coordinate and the y-coordinate of the vector, of the tail, the head of the vector. With parametric functions, position is given by x of t and y of t. So the position vector is x of t, y of t. Velocity vector is the derivative, and the acceleration vector is the second derivative. Find the magnitude of the vector and the direction angle theta it forms with the positive x-axis from 0 to 360. So we're going to make sure we put our calculator into degree mode. Let's draw the vector. It's at 2, 2, right there. And we need, let's go magnitude. So if we call this vector v, the magnitude of vector v is equal to the square root of 4 plus 4. Square root of 8, so 2 square root of 2. Now the tangent of this angle right here, the tangent of theta is equal to opposite over adjacent. So to get the angle, we need inverse tangent of 1, which we know is 45 degrees. This one over here, we have negative 2, 1, 2, 3, 4, 5. So there is the vector, called vector v. And the magnitude of vector v is square root of 4 plus 25, which is square root of 29. Now, the tangent of theta is equal to, well, it's opposite over adjacent, or we could say y over x, or sine over cosine. So it's 5 over negative 2. So the angle is the inverse tangent of negative 5 halves. But there's a little problem when we do this on the calculator. We got negative 5 halves. It tells us that it's negative 68 degrees, which is actually down here, which is the principal quadrant of tangent. So to get our answer, we have to add 180. So we're going to do this plus 180. Plus 180, and we get 111. 111.801 degrees. Find the component form of the vector with the given magnitude that forms the given directional angle with the positive x-axis. So what are we doing? Find the component form. 180 degrees on a radius of 4. So it's on a circle of radius 4 at 180 degrees. Well, I know that this point is negative 4, 0, but how are we going to do that? I mean, how would we do that for number 13 where it's not as nice? Well, the component form is radius times cosine of theta and radius times sine of theta. And in this case, it's 4 cosine of 180, 4 sine of 180. And the cosine is negative 1, and the sine is 0. Well, now we're going to do the same thing with 5 100. And we don't have to draw it, but that would be a representation right there. There's 5 100. So we need 5 cosine of 100. 5, that's a 5. 5 sine of 100. So 5 cosine of 100 degrees and 5 sine of 100 degrees. Negative 0.868 and 4.924. A particle moves in the xy plane so that anytime t greater than 0, the position of the particle is given by those functions. Sketch the graph from 0 to 1.2. Let's go mode, parametric. Let's go y equals t plus 4t squared and t to the 4th minus t to the 3rd. And our window is 0 to 1.2, and then 0 to 10, and negative 1 to, whoop, that's the scale, clear 1, negative 1 to 1 graph. And it looks something like this. Oh, that's probably a little too far. It doesn't quite get to 7 if I look real close. Plot the point P when t equals 1. So let's plug 1 in for these, and we get 1 plus 4 is 5, and 1 minus 1 is 0. So when t is 1, we're at the point 5, 0, right there. Find the velocity vector at the point P and sketch the velocity vector at point P. Well, if we said, I'm going to erase this, but if we said, what's the direction this particle is going when it's right there, we'd probably do this. That's the direction it's going, at least for that brief moment of time. And then right down at the bottom, it's probably going horizontal for a brief moment of time. So I'm expecting the velocity vector to do something like that. That's the direction that particle is going, at least for a brief moment in time. Find the velocity vector. So v of t is equal to, we do the derivative of these, 1 plus 8t, comma 4t to the 3rd minus 3t squared. And we're going to evaluate, so v of 1, when t is 1, is going to be 9 at 1. Now we draw that vector starting here, where we're at. We're at 5, 0, and so it's like we have this new xy axis here. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And this isn't to scale, but the 1 is way up here. So that's the direction the particle is going roughly. Give the direction and speed of the object when t is equal to 1. So we'll have to add that in there. Give the direction, and how about speed? Let's go with speed. Speed is equal to the magnitude of the velocity vector. So 81 plus 1, we're squaring, doing the Pythagorean theorem on that vector right there. Square root of 82, which has to be very close to 9 actually. Square root of 82 is 9.055. 9.055, maybe feet per second, miles per hour, whatever it is. And how about the direction? The direction is inverse tangent of y over x, which is 1/9. Inverse tangent of 1/9 is 6.340 degrees. Now this isn't really to scale. If it was to scale, 1 would probably be right there. So there's where we would really kind of more visually see that it's 6 degrees. Find the acceleration vector when t equals 1. A of t is the derivative of the velocity, so that's 8 and 12t squared minus 6t. And we'll evaluate that when t equals 1, and we get 8, 6. Find the total distance traveled from 0 to 1.2. Well, with parametric, we called this length of the curve. And we got it by doing the integral from 0 to 1.2 of square root of dx dt squared plus dy dt squared. In other words, we do the Pythagorean theorem on the first derivative, on the change in x and the change in y. Well, here with vectors, now we're just calling it distance traveled. And now it's integral from 0 to 1.2 of, the velocity vector. The velocity is the first derivative. So the velocity is the change in the position. So it's the x coordinate of the velocity squared plus the y coordinate of, or the component of velocity squared dt. So we're doing the same thing we did with parametric. So to answer the question, it's integral from 0 to 1.2 of square root. I need velocity. So here's the velocity vector up here. 1 plus 8t squared plus 4t to the third minus 3t squared dt. But this curve doesn't curve all that much. It's going from 0 to almost 7 and curves very little. Remember, that's only up there at 1. That's only -1. So this has very little curve to it. It's practically straight if we drew it to scale, which means that the distance should be somewhere around 7. It shouldn't be that much different. There's not a lot of curving to be done. Now, if this did this and here and there, then it'd be hard to decide how long it actually is. All right, so let's get it and let's see if the answer ends up being somewhere around 7, like we're kind of predicting. 1.2 square root of, we're going to go 1 plus 8t squared plus 4t to the third, that's to the sixth, to the third, minus 3t squared, and that's squared, and dt. Be somewhere around 7. Hey, 6.997. 6.997. Example, the position of the particle at t greater than or equals 0 is given by those two equations. Sketch the position. This is almost the unit circle because x is cosine, y is sine. This would be the unit circle right here, but this has been stretched along the x by 4, stretched along the y by 2. So this would be pretty easy to graph this. It ends up being an ellipse. And it starts over here where the unit circle would be, and the unit circle goes in a counterclockwise direction like that. Find the velocity vector and graph the velocity vector when t is equal to pi over 2. So let's find out, well, where are we when t is pi over 2? And so we'll plug that into the position. This is going to answer the question, where are we? cosine of pi over 2 is 0, and sine of pi over 2 is 1. So we're at the point 0, 2. This is when t is pi over 2, we're up at this point right here. Now we need the velocity vector. That's negative 4 sine of t and 2 cosine of t. And now v of pi over 2, sine of pi over 2 is 1, so negative 4, and cosine of pi over 2 is 0. So negative 4, 0 is the velocity vector, but we're plotting the velocity vector up here at the point that we're talking about. So negative 4, 0 is over this way. So this is the direction the particle is going at the very top, and the magnitude is how fast it's going. So it says, what is the speed of the particle? So the speed is equal to the magnitude of the velocity vector, which is the square root of negative 4 squared plus 0 squared, which is square root of 16, which ends up being 4. And when it's a horizontal vector or a vertical vector, it's pretty easy to tell what the length is. Now, when it's at an angle, then that's a little harder, and we got to use the Pythagorean theorem for sure. Particle moves in the xy plane so that anytime t, its coordinates are the following. At t equals 1, its acceleration vector is what? So v of t is 3t squared 2t minus 3, and the acceleration vector is 6t 2. Does it say, at t equals 1, so a of 1 is 6, 2. If x is t squared minus t and y is 4t plus 1, find the equation of the tangent line when t is equal to negative 1. We need a point, and we need a slope. If I plug negative 1 in here, we get the point. So let's see, 1 plus 1 is 2, negative 4 plus 1 is negative 3. But to find the slope, we need dy dx. The derivative of y is 4, and the derivative of x is 2t minus 1. Now we're evaluating that when t is negative 1. So 4 over negative 3, so negative 4 thirds. The tangent line is y plus 3 is equal to negative 4 thirds times x minus 2. Now, I plotted this on Desmos to kind of show what did we actually find. What is going on here? There's the curve, and we have the equation of the tangent line at the point 2, negative 3. So 2, negative 3, there it is. And if you zoom in on it, you can see that that's actually the point, 2, negative 3 right there, and there's the tangent line to the curve. Find the second derivative. So dy dx is 4t to the third over 3t squared, which is 4 thirds t. Then the second derivative is the derivative of the first derivative, 4 thirds, but then divided by dx dt again, 3t squared. So it ends up being 4 over 9t squared. These are the equations of a projectile right here in parametric form. A baseball leaves a batter's bat at an angle of 60 degrees from the horizontal, traveling at 110 feet per second. A fielder who is standing in the direct line of the hit with his glove at a vertical reach of 8 feet catches the ball for the out. His feet do not leave the ground. Well, the theta is the 60 degrees, and the initial velocity is 110. So letter A, find the position vector of the baseball at time t. X of t is v naught t cosine of 60. And then we have 110 t sine of 60 minus 16 t squared. And those equations are up there at the top. Cosine of t is a half, so 55t, and sine of 60 is square root of 3 over 2. 110 square root of 3t minus 16t squared. B, find the velocity vector of the baseball at time t. So v of t is 55. Oh, not 110. I forgot to take half of that. That's 55. All right, 55. So that one is also 55. 55 square root of 3, 32t. Letter C, at what time t does the fielder catch the ball and how far is he from home plate? Well, he'll catch the ball when the ball is 8 feet high, but it's going to be 8 feet high going up that when the batter hits it, and then when it's 8 feet high, that's when we know the ball has been caught. Well, the height is the position. It's the y coordinate of the position is the height. So we want to know when 55 square root of 3t minus 16t squared, we want to know that when that's equal to 8. Well, that's a single equation, so we're going to go mode function y equals 55 square root of 3 x minus 16t squared. We want to know when that's 8. So if we go zoom 6 here, there's the parabola. You can kind of barely see it, but there's when the height is 8. Now we want to know the intersection. Calculate number 5 in intersection first, second. And it seems the intersection is right around 5, so I'll guess about 5. And it's actually 5.868. So t is 5.868 seconds. But it also says, and how far is he from home plate? Well, that's this right here. That'll be the distance, the horizontal distance from home plate. So we need 110 times, well, no, I can use the 55, right? I can use the 55. So it's just going to be 55, let's get out of there. X holds that value. X holds that time right there. So it's 55 times X. So 322 feet. So 55 times the 5.868, and we use the non-rounded version in the calculator, is 322.780 feet. Jeez. D, how fast is the ball traveling when he catches the ball? Well, that's the magnitude of the velocity vector. So the speed of the ball is equal to the magnitude of v of the 5.868, which is equal to the square root of 55 squared plus 55 square root of 3 minus 32 times the 5.868. But I won't use, I need that squared also. But I'll use the calculator for that actual value. Square root of 55 squared plus 55 square root of 3 minus 32. Is it just, yeah, it's minus 32 just times t. So times x and then that squared. Like that, and that should get it for us, 107. So a 107.647 feet per second. The magnitude length of that vector is, well, it's the Pythagorean theorem. Particle moves in the xy plane, so anytime t greater than or equal to 0, the position of the particle is given by that. Find the magnitude, the velocity, or the speed vector when t is equal to 1. So the velocity vector is 2t plus 3 and 3t squared minus 6t. And we're going to do v of 1, which is 5, negative 3. Oh, wait, that's not it. That is, we did the component form of that. And now I almost didn't actually answer the question. Square root of 25 plus 9, square root of 34. That's the speed. If a particle moves in the xy plane at any time t greater than or equal to 0, its position vector is that. What is the velocity vector at t equals 1? Find the speed. What is the velocity vector? So the velocity vector is 3 over 3t plus 1 and 6t. Yeah, there's the velocity because that's the position. Is that it? Find the speed of the particle at t equals 1. So then if we evaluate this when t equals 1, the component form ends up being 3 fourths and 6. So now the speed is equal to the square root of 9/16 plus 36. What's 36 times 16? And add 9 to that. 585. So square root of 585 over 4, and we can get some decimal value for that. That's all right. Write the integral to calculate the distance a particle travels on the path. Do not evaluate. So the distance traveled, that's the integral from 0 to pi over 3, but we need some derivatives here. Dx dt is equal to 2 sine of t times the cosine of t. So that's going to be the square root of 4 sine squared t cosine squared t. We got that squared. Now I need the derivative of this right here. So dy dt is equal to 3 cosine squared of t times negative sine of t. But we need to square that as well. 9 cosine to the 4th t times sine squared t dt. This is from your assignment. Number 27, a particle travels in the plane with position vector r of t. Find the velocity vector and the acceleration vector. So velocity is 6t squared. And then the acceleration vector is 6 and 12t. Particle moves in the plane with position vector. Find the velocity and acceleration vectors and determine the path of the particle. So find the velocity vector. Negative 3 sine of 3t and 2 cosine of 2t. And then determine what about velocity and acceleration. A of t is negative 9 cosine of 3t and negative 4 sine of 2t. And then finally it says use your calculator to find the path. Oh, we want to go back to parametric mode. Y equals, clear that. So x equals cosine of 3t. And then we have sine of 2t. I need to be in radians for sure because this is trig values. And we'll see how big it is. We'll go zoom 6. Oh, it's tiny. Window. 0 to 2 pi. How about negative 3 to 3? Negative 3 to 3. Let's see how that fits right there. Okay, that's yeah, okay, all right. Let's give that a shot. Like this. Ugh. Yeah, no. Go through the middle. Go through the middle. And then there's then that's kind of like this guy right here. Something like that. Yeah, that'll work.